In section 4.5, we look at another way to graph linear equations. And this is a very popular traditional method called slope-intercept form. So slope-intercept form is an equation of a line that has this form, y equals mx plus b, where m is the slope and b is the y-intercept. So for example, if we look at this equation, y equals 2/3 x minus 5, we know from this equation that the line has a slope of 2/3, that's the coefficient of x, and a y-intercept of -5. There's the y-intercept, the constant by itself. And to graph a line using slope-intercept form, first of all you can plot the y-intercept, then use the slope to plot a second point. So you'll see an example of this in just a moment. And then that will give you the 2 points that you need. Remember, you only need 2 points to determine a line. So once you have those 2 points, connect them and you have your line. And speaking of slope, we want to look at the idea of parallel lines. These are two lines. First of all, they have to be in the same plane and they will never intersect. And it turns out that parallel lines that are non-vertical will always have the same slope. And vertical lines that are in the same plane are parallel to each other. So remember, vertical lines have undefined slope, so they don't really fit that first rule, and that's why we have that special requirement there of non-vertical lines. So let's jump into examples and see how this works. Identify the slope and the y-intercept of the line with the given equation. And in the first case, we're in luck because this is already in slope-intercept form. So the slope is the coefficient of x, which is 3, and the y-intercept is that constant by itself, 5. Okay, nice and simple, right? Number 2, 4x plus 2y equals 10. We want to get y by itself. So I'm going to subtract 4x from each side first. So we still have 2y on the left-hand side. And remember, we can write either 10 minus 4x or negative 4x plus 10, and then divide by 2. So we get y equals negative 4x divided by 2 is negative 2x, and then 10 divided by 2 is 5. So now that the equation is in slope-intercept form, we can readily identify the slope as negative 2 and the y-intercept as 5. Number 3, now we finally get to the idea of graphing an equation using slope-intercept. Graph the equation y equals 2x minus 4. This is already in slope-intercept form, so we know that the slope is 2 and the y-intercept is negative 4. So we can start with the y-intercept at negative 4. So 1, 2, 3, 4. There's our negative 4. And then remember that a slope of 2 we can rewrite as 2 over 1, or we could even write it as negative 2 over negative 1. And remember that this is rise over run, or the change in y over the change in x. So in other words, from our y-intercept of negative 4, we can either go up 2 and to the right 1, or we could go down 2 and to the left 1. And in this case, there isn't room to go down 2 and to the left 1, and so I'm going to go from the y-intercept up 2 units and to the right 1. So there's a slope of 2. You could even make another point if you wanted, go up 2 and to the right 1, up 2 to the right 1. But if you have a straight edge, then you can just go ahead. Ooh, wow, sorry, there is something going on with this. There we go. That's a little bit better. Having problems with my input device. Okay. Number 4, graph the equation y equals negative 2/3 x plus 1. So again, this is already in slope-intercept form. We know the slope is negative 2/3 and the y-intercept is 1. So the y-intercept of 1, I'm going to go here at 1, and with a slope of negative 2/3, we can either look at that as negative 2 over 3 or 2 over negative 3. So in other words, we can either go down 2 units and to the right 3, or we could go up 2 units and to the left 3. Okay, so negative divided by a positive is negative. Positive divided by a negative is still negative. So then we can draw our line going through those points. Remember, you only need 2 of those points. I just drew in 3 to verify and to show that you have 2 different options going from your y-intercept. In number 5, graph the equation negative 4x plus 4y equals negative 8. Here, we want to put this in slope-intercept form first. So because it's a negative 4x, I'm going to add 4x to each side. Oops, that's a plus sign. And so we get 4y on the left-hand side, and we have a positive 4x on the right-hand side minus 8. Then divide by 4, and we get y is equal to 4x over 4 is simply x, or 1x, minus 2. Negative 8 divided by 4 will give us negative 2. So we have a slope of 1. Remember, if there's no coefficient in front of x, it's 1. And a y-intercept of negative 2. So for a y-intercept of negative 2, we go to negative 2. Whoops. And then a slope of 1, we can either go up 1 and to the right 1, or we could go down 1 and to the left 1. Remember, negative divided by negative is positive. So we have our slope here going through our y-intercept at negative 2, and there's our graph. Okay, number 6, determine if the line 4x plus 3y equals 15 is parallel to the line y equals negative 3/4 x minus 9. So parallel lines, as long as they're non-vertical, same slope. So that's what we have to test for. Do they have the same slope? So let's look at this line in blue, and we'll look at this one in green. In the case of the green, we already know our slope because we have the equation in slope-intercept form. So slope is equal to negative 3 over 4. Now let's look at our first equation. 4x plus 3y equals 15. And I'm going to subtract 4x. So we get 3y is equal to negative 4x plus 15. And then divide by 3. And we get y equals negative 4/3 x plus 5. So here we have a slope of negative 4/3, not the same as negative 3/4, and therefore no, these lines are not parallel. So they are not parallel. By the way, when you're doing a problem like this, if somebody's really tricky, they could actually give you the same line in 2 different forms. And so first of all, you need to compare the slope. If they have the same slope, then you would also have to look at the y-intercept. And if they have the same slope and the same y-intercept, then they're the same line. If they have the same slope but different y-intercepts, then they're parallel. In this case, we don't have the same slope, so they are not parallel. Number 7, the graph below shows the cost for hiring a taxi based on the number of miles driven. Find the slope and the y-intercept of the equation and explain what they represent. So 2 parts to this. First of all, find the slope and the y-intercept, and then determine what those actually mean. What do they represent in the problem? So the slope is, if we're going from, let's see, this is going by ones here, so 1, 2, 3. We can pick 2 points if we want. So for example, here we have a point at 0, 3, and let's make another point at the intersection of 2 grid lines. And by the way, it's generally a good idea to try to pick points that are a little bit further apart from each other rather than right next to each other. So that way, if there's a little bit of a mistake there, as you stretched out and have a little bit of a mistake on a longer line, that's okay. So we have a slope of, let's see, we have a point of 0, 3, and another point here at 1, 2, 3, 4, 5, 6, and that's also 6, 4, 5, 6. So our second point is at 6, 6. So to determine the slope, we'll take 6 minus 3, the change in y, over the change in x, which is 6 minus 0, which is 3 over 6, which simplifies to 1/2. So here the idea of slope relates to rate of change. What that means is you get charged, so the charge is 50 cents, $1/2. So 50 cents per mile. And then if you look at the y-intercept, look at the y-intercept, we already have it right here. It's 3, and what that means is you haven't driven anywhere, you just got into the taxi, and that's your cost just to get in. So you could word this a few ways. The initial charge, for example, is $3. Okay, so basically it costs $3 just to get in the taxi and have the driver start the meter, and then as you drive it will cost 50 cents or $1/2 per mile. Alright, so there you go. Again, remember that this is a real common, very traditional method of graphing, and so you're probably going to run into it frequently. So enjoy slope-intercept form. Good luck.